So today I'm going to introduce Prashan Madumal from the AI and Autonomy Lab at the University of Melbourne. Prashan is currently teaching AI planning and machine learning and working on his PhD thesis on explainable reinforcement learning. So his approach is grounded in causal model, and the title of today's talk is a causal explanation for reinforcement learning agents. So I will now let Prashan start. Thank you once again. And,
thanks, Sylvia. Maybe I'll share the screen. I think the screen is visible.
Yes.
Yeah. So, all right. So this is joint work done with my supervisors, Tim Miller, Lee Sonnenberg, and Frank Vittori at the AI and Autonomy Lab at University of Melbourne. So the title of the talk is Causal Explanations for Reinforcement Learning Agents, right? So I'll kind of touch upon what explainability is. Some of you might be very familiar with this, but I'll touch upon that, and I'll explain how we can provide explanations for sequential decision-making agents like reinforcement learning agents and robotics as well. All right, so what is explainable AI? So this is like a hot topic these days, and this surfaced, this term explainable AI surfaced in 2016 with the DARPA XAI program, but it was really the problem of explainability has been around since the expert systems, right? So since the expert systems, we wanted to know what's happening inside a system, AI system, and we wanted to kind of question the system and understand the reasoning behind the decisions that those systems make, right? So explainable AI can be explaining decisions and actions and behaviors of an AI system. So it comes in different flavors. So these days we can kind of separate these into three main categories. So the most famous one is interpretable machine learning, which is mainly trying to understand or explain things in machine learning models like CNNs, deep learning models like visual. So mostly these are visualization-based explanations, like trying to understand the concepts in an image and based on those concepts explain what is going on. And some of these methods try to build a surrogate model, a much simpler model than the actual underlying model to explain things. So one of these, this is a simple example I did with research I did with my colleagues, which was published in last year AAAI, which we tried to explain the concepts, explain an image using the concepts that inside that image. You can see there's these images of dogs. It's not really clear, but it kind of separates the image to different concepts. And then there's explainable agents, which is mainly trying to explain sequential decision-making agents. So there are many categories in this. One is explainable planning, and another is explainable reinforcement learning, which is the focus of this talk. So this is another kind of seminal work in this area in explainable planning, work of Tathagata Chakraborty, where you can explain plans based on mental models or model matching. There are also work that relates to human factors and cognitive factors, because these explanations are basically an interaction process, right? So there's few different aspects of an explanation. When we try to provide an explanation, there's also a cognitive aspect, right? So we have to communicate that explanation to a human. So there's a lot of work ongoing and past work that focuses on these human factors, like mental models, interactive explanations. So these two articles I just cited, these Tim Miller's article on explanation in artificial intelligence, insights from social sciences, kind of uh, uh, give a great overview of cognitive factors and human factors in social sciences, because explanations are not just, it has been studied in different disciplines like cognitive science and social sciences. And this is a very good article to get an overall understanding. Also, another good article is Miller's this meta review of explanations in human AI systems. So that's kind of like an overview of the different flavors in XAI. And so I like to use this diagram to kind of categorize these different flavors into one agency. So we call this explainable agency. So explainable agency is the ability an agent should have to explain their decisions, right? So you can see there's like two different sections. So there's explainable models, which are models that can be explained. So these can be surrogate models that are more abstract and simpler. And then there's the explanation generation. So we need to actually devise methods that can generate explanations from these explainable models, right? And then we need to have some method to communicate that generated explanation to a user or a human. So these are broadly called explanation dialogues. So when taken together, these three forms the explainable agency. So today's talk would mainly focus on these two areas. How can we build an explainable model, and how can we generate explanations from that model, right? And my focus area has been in generating causal explanations using causal models. There's a lot of reasons why I went through this path. These reasons are rooted in different disciplines as well, but I'll talk about more on that in later slides. But my focus is on providing or generating causal explanations. So to put simply, a causal explanation is just explaining the causes behind a certain event, right? So we can take this wet rod event as the event we want to be explained. So you can ask a question like why the rod is wet, and you can see there's rain is the cause of the rod being wet, right? So we can provide the explanation as because it rained, something similar to that, right? So this simple kind of diagram can be taken as a explanation model, right? Explainable model. So we can then generate an explanation using that explainable model using different methods. And this we usually this type of diagram is known as a causal diagram. I won't go into much detail to explain causal diagrams because I would be explaining my own work relative to that. So for now, just think a causal explanation is something that explains the causes behind a certain event. So yeah, there's good reason to make causal explanations, so provide causal explanations instead of any other explanation. So a lot of theories in cognitive psychology shows that humans usually understand the world in cause and effect manner, right? So that makes causal explanations natural and more intuitive, and this also makes sense to use explanation models that that is more familiar to humans, right? So these are like Pat Langley's work emphasize this to use more natural models. So that's why my inspiration came from those articles that said we should use natural models, and also in cognitive sciences, people say, researchers say that causal explanations are the better kind of model to use. So yeah, so how can we provide causal explanations for reinforcement learning agents? So this the talk is mainly based on this paper, Explainable Reinforcement Learning Through a Causal Lens, that was published in last year's AAAI. You can read the paper through this link. Yeah, so for those who are not familiar with reinforcement learning, I like to use this diagram to explain. So there's this mouse who wants to find, who we want to train to find the cheese through the maze, and you can provide positive or negative rewards, and through repeated trials, we can enforce the behavior, and the mouse would try to find the shortest path to this cheese, right? That's the same thing for agents. We have state variables that describes the world, and actions that the agent can use to act in the world, and rewards that you would get back from the environment. And there are a fair bit of work in explainable reinforcement learning. Early work mainly focused on providing explanations based on relevant variables. That means how a certain variable affected the value of the state. So this would only explain one variable in a state. And other work usually provides policy explanation. So the first one usually provides an explanation for an action. Sorry. We usually call them local explanations, and the policy explanations usually provided more global explanation, like we describe the behavior of the agent in its entirety. So we call them policy explanations, so more broadly global explanations. And there has been also been work on policy summarization. That means we are going to summarize the overall behavior into a more compact explanation. So Ofra Amir's work has been focused on those kinds of explanations, highlights, for example, the highlights algorithm. We proposed a new model, explainable model called action influence graphs. So these graphs are causal graphs. I showed a simple causal graph before. Similar to that, these are causal graphs, but the main difference is this causal graph is augmented with an action, right? Because agents have actions, and these actions can affect the environment in a causal way. So we wanted to kind of reflect that in the causal diagram. So usually normal causal diagrams don't have anything labeled in the edges. So we in the action influence graphs, the difference is we have actions annotated as the edges. And the purpose is to learn the causal effect between two variables. So these variables are the model of the agent inside the what are inside the agent's model. And we can then use this causal action influence graph to generate explanations. So these explanations are generated for why and why not questions. So if I ask, why did you do action A from an agent, we are able to generate an explanation using this graph. A bit of formalization. These action influence graphs are based on structural causal models. So don't worry too much about the formalization. It's just saying we have a model, a causal graph, and each of the edges or variables are described with a structural causal equation. And we can use these structural causal equations to actually develop action influence graph as well. So we extended this to action influence models, and might be easier to understand with an example. So take a small example like this, like two variables, you have a causal relationship with W and S variable, and there's an action, right? So that simply you can say variable W influence variable S by performing action A. So you can represent this using an equation like this, a linear equation like this. So this is a more complete kind of action influence graph. So this is for the star graph domain. You can see there's different variables, state variables, and different actions. And these different actions can form a graph like this. So we can use this graph to ask different questions, right? So if I ask the agent, why did you do action, uh, any action from this list? Let's say AS. You can see you can find the action AS in this graph AS, and you can generate the explanation based on that. So how we generated the explanation is you follow this causal chain to the reward nodes, right? So the reward nodes are the sync nodes of this graph. So you have DU and DB here, and you just simply follow the reward nodes and you can provide an explanation. You can also ask a why not question. So for example, if you ask why not AB, then you have to, so the tricky part is actually answering the why not question. Why not question, you have to answer a why not question, you have to simulate a counterfactual state or a counterfactual world. So when I ask a why not question, so for example, if I ask why not build barracks, that's the action AB. So you have to actually simulate that the state of the world and say, okay, I'm not building barracks because these variables are these values, right? So in that case, you have to actually apply the structural causal structural equation. So remember I said we have an equation associated with each of these edges. These are simply linear equations. So you can get the value of B by applying value of W to that equation, right? So this edge is associated with a certain equation, and you can get the value of B by applying that equation, and you can forward simulate that and get these every value. And then what you do is you compare these two causal chains of those two actions, and then you get the difference, and then you can provide a why not question. So simply we are trying to see what's the difference between a simulated world and what actually happened, and then we compare the differences in a causal manner, and we just provide the difference as the explanation. So yeah, so I kind of explain this explanation for why not questions. We can provide contrastive explanations using that, and also simulate counterfactual worlds. So if you might have questions on this, I'm happy to take questions after this. So how did we evaluate this? So we used different OpenAI gym domains like cart, pole, mountain, car, taxi. These are good domains to evaluate on because they are widely used, and we used different reinforcement learning algorithms as well. So these our model is not dependent on any specific reinforcement learning algorithm. It can work on any algorithm. So you can think of the model as a surrogate model, actually. So we are not using the action influence graph to make decisions for the agent. We still have the underlying actual reinforcement learning algorithm that is making decisions at the runtime. And you also have the action influence model that is used to generate explanations. Yeah, so we also tested StarCraft domain. So we got a good accuracy on that. So we were trying to see, can we use the surrogate model to predict actions and compare that against the actual policy of the agent. So we got acceptable accuracy. So the point of doing this computational evaluation is to see is the model kind of is true to the actual behavior of the agent. So if it's true to the actual behavior of the agent, we can use that surrogate model to provide explanations. So a bit about the StarCraft 2 domain. It's a good domain to play around with and use for research. That it has been widely used for research as well as for explainability research as well. Yeah, so you can, I'm not going, I think I had a video ready, but I think I'm going to skip the video for now. So you can ask questions like this and provide So I just use, for this textual kind of templates, I just use a natural, simple rule-based template. What you get is from this, the actual generation output of this model would be the nodes of the causal chain. And through that node, you can generate any explanation you want using a natural language template. Right, so we also did human evaluations. So the point of doing human evaluations is to see how the explanation generation process and the explanation model, explainable model, fare in actual real world situations by providing by testing them on users, right? So what we did was we compared 3 baseline models. We gave the users no explanations, just a visual explanation. And we also used the state action relevant variable based explanations of Khan. And then we gave the causal explanations. And we used 3 kind of metrics. So the first one is important metrics, task prediction. So after we gave the videos to users, and then we allowed the users to ask questions based on those videos. So they were free to ask questions on any action. So they can ask why action A, why action B, why action C, or why not action A, why not action A, B, or so on, right? So we had 4 actions for the domain, and they can ask any number of questions. So the point of letting them ask question is to have them understand the agent. We wanted to make the humans or the participants understand the agent's behavior using explanations. And the second part of the experiment was to evaluate their understanding. To do that, we use task prediction. So this is, again, we would give a video and then ask the user, what would the agent do next, right? So if the participant has a good understanding of the agent based on the explanations provided before, they should be able to predict the agent's behavior. So we usually call that task prediction. And we also evaluated explanation quality and the trust. So we got pretty good results on task prediction. You can see this, the white one is the causal explanations, and as we expected, we got significantly better results than other baseline. In the explanation quality, we got as good results as well. But for trust, we actually didn't get significant results. So this was really interesting because to generate trust, we actually needed a longer interaction time, but our experiments didn't really provided that, right? So to build trust with the system, we need to interact with it in more occasions and more often. But in our experiment, it was very limited interaction time. So we think that might be the reason for these results. And yeah, future directions. So this action influence models can be extended. So right now we don't actually consider the abstraction level of the agent. So you can have different abstraction levels and different causal models for those abstractions, right? So we wanted to explore that as well. And one of the most critical kind of major drawback in our methodology and the model is the need of having a causal model, a ground truth causal model of the domain at hand. We need to craft that by hand, but we wanted to kind of learn that end to end as well. So we actually have some results, and we did some work on that, but I won't talk. I can talk about that if there are any questions. But what we do is we try to learn the causal model at the runtime of the agent. So we are actually learning this structure of the graph as well. So in this particular work, we had to provide this structure of the graph, but in the latest work, we are learning the structure as well. So in our latest work, we are doing this end to end. And we also, I think I didn't add a slide for that, but we also extended this to a different type of explanations, what we call a digital explanation. So we did that by analyzing human data that we obtained from the experiments. So we let the participants to provide their own explanations, and we actually analyzed those explanations and then implemented the new explanation type based on those analyses. So as a conclusion and the takeaway message, I would say, is to see causal explanations are intuitive and natural to humans. So our idea was to use this try to generate a causal model and learn a causal model at the training time that allows us to reason about counterfactual explanations and generate contrastive and counterfactual explanations. And the results indicate that human subjective results and also computational results indicate that this shows some promise in the explanation, providing explanation for reinforcement learning agents. And that is it. I would be happy to get some questions.
Thank you, Prashan, for the great talk. Do you have any question? You have also people who are clapping and doing reactions.
Let me see the chat. Are we looking at the Slack or the chat?
No. At this point, we are asking people to
right.
questions.
Got it.
Then, if there is no much time, if people have additional questions outside the live session, then Slack is a good option.
Right.
So, any question? If you don't have any question, and I can open with a question, but I would be happy to hear from you.
I think there's one. I think Akib wants to make a question.
Okay, cool.
I have a question. Yep.
Yes.
First of all, great presentation. So I have a question on the causal explanation. So one of the things which I usually struggle with causal explanation, which you have done, is like determining this causal chain. Like, for example, in your example which you gave, like, oh, the road is wet because there was a rain. But the causal explanation or the cause can have a multiple reason, like road is wet because water makes the road wet. So there can be many reasons for a road to be wet, but humans, basically, when they're asking for a question, they look for a particular causal explanation, and that is very contextually dependent. So I'm more curious about how your method of like using this graph model would help that, or kind of action influence graph model, or kind of mitigate it, or do you have any thoughts on that?
Yeah, so if I got your question correctly, you're talking about like multiple causes and how we can kind of identify what cause to select in order to provide the explanation, right?
Yes, so there are like multiple causes, and humans usually prefer a particular cause for explanation. Like for an event can have multiple reasons or causes, but the humans basically say like, oh, why this happened? Like, for example, in your case, the road was wet because rain happened, and that is the reason. But you can also give that road is wet because water makes the road wet.
Right. So you are talking about like having multiple kind of like causes in this multiple nodes connected to this wet road node, right? Yeah. So so this same kind of problem exists in this action influence model as well. So we can have multiple causes for a node, but that only happens if you consider providing explanation for a node in this case. So we don't usually ask a question for a particular node. So a node in this case is a feature, right? A state variable. So we would not ask a question like why was state A, the state S this value. We would ask a question about an action, right? So in this, what this graph provides is the easy way to map the causes or the causal chain of an action. So you can see that if you take action AS, this has a clear causal chain that leads to the rewards, right? So the way we constructed this graph is to have rewards as the sink nodes. So rewards would always be included in the explanation. And this would also have nodes that are intermediate to this causal chain. For if you take AS as an example, so if I ask why the agent did action AS, so you can see this like bold causal chain going into DU and DB and going through S and AN. So at this point, we need to, so imagine if the causal chain is long, that means we would have a lot of causes to explain, right? So, but like we can't provide, like let's say there's the causal chain is 10, has 10 nodes, but we can't provide 10 causes as the explanation. So what we did was we tried to provide the most immediate cause, which is the immediate influence, which is in this case S, and the reward nodes, which is DU and DB, and the immediate nodes preceding the reward nodes. So that way we kind of we call them. So this also exists in other literature as well. We call them minimally sufficient explanations. We are not providing every cause, every causes or every features or every relevant variable. We are just selecting some of them. So that selection can be another thing as well. So we used this kind of heuristic just to have rewards and the most immediate cause. So this is also based on some social science literature that says we want to have more information about the most immediate cause and the kind of a distal kind of cause. So the rewards can be as thought of as a long-term goal. But you can also provide or select these causes in a different way as well. So it all depends on, I guess, the context as well.
I have another follow-up if no one has a question, but if not, I'll not ask.
If there are no other questions, I can. Okay, Mr. Glenda.
Yes. Yeah, thank you a lot for the talk. I think my question also relates a bit to what Aprip said. At some intuitions that are maybe a bit difficult to understand from your talk. So maybe it's more about maybe explaining it a bit more. But my thought is that causal explanations we normally use to explain natural phenomenon because there are these change. But then we have also in a social, if you add the social layer that we see between humans, it isn't always about the causality or the understanding how did one action or event lead to another. And when we make explanation or ask for explanation, we often really want to know the intention behind the action. And the question is, how does this notion of intention fit into your model and your framework? And at least in my view, it's also maybe not completely true to say that causal explanations are very intuitive to humans, because in the philosophy of science, we have also a lot of discussion that if the phenomenon is in a sense local, so we can observe that, okay, the street is wet because it's been raining or something, it's because we have a more immediate access. We have some constraints to say, okay, we can look out the window or we can make tests, but then you also have these global phenomena like the theory of evolution which you don't observe in the same way, and there people have really difficulty sometimes understanding how can one event lead to the other, and how did we get to this point? So I think it's important to distinguish between these local and global events, but also where does intention play into your model of explanations?
Yeah, it's a really good question. So in my work, I mainly focused on providing local explanations because we ask, why did you do action? So action, when you say action, it's kind of have a local context for the agent. But I know what you're like what you're talking about is mainly on, I think, touches upon also theory of mind and those kinds of work. So there are a lot of work done on theory of mind and explanations, like explaining agents using BDI kind of models. So I think that's a really good direction as well. So providing explanations based on intentions, goals and desires of the agent. In that case, we need to explicitly model the agent based on those criteria, right? So it's another kind of, I guess, another layer of abstraction as well. So in this work, we focused on like abstracting the agent's behavior into a causal kind of framework, but you can also abstract that into like belief, desires, intentions, and then generate explanations based on that. For I guess intentions, like goals, I guess rewards usually touches upon goals, kind of have a similarity between goals and rewards. So there can be like long-term rewards that we can kind of say they are the goals of the agent. But yeah, this doesn't explicitly model that sort of behavior, I would say. But yeah, that's an interesting kind of direction as well.
Okay, I actually have a question related to this, but if Akin want to go first, and if there are no other questions first, do you have any other question?
Yeah, I can go if that's fine.
Okay.
Cool. So my thing is again kind of same with the intentions and reward. Like as you mentioned, rewards kind of defines why an agent is driving towards a particular goal. But in your model right now, you're looking more at the causes. So one of the things which I've noticed, at least in explainable RL, is like these rewards are very sparse and they are trained over a period of time, like so many episodes. So we don't know why a particular action is caused because it is over the period of time and it is collapsed into a single scalar variable. So is there a way to what are your thoughts on that in that sense?
Yeah. So when trying to kind of model or like extract the action influence graph from the underlying like simulator. So the simulator for an RL agent can provide, as you said, like a sparse reward, right? So sparse reward might be, in this case, in the star graph, just winning the game or losing the game. So that just happens at the episode end time, right? But there can be also rewards that like usually get when you have not doing an action, but being in a particular state or using a particular variable, right? So this, I would say it is difficult to model a sparse reward, but it's doable. It's like you can have a reward, a node that's for in this particular example, winning directly relates to the reward of like destroying the agent's base, like buildings. So that's directly relates to the sparse reward at the end. So in that way, we modeled it as that. But yeah, in certain kind of domains, it might not be possible to actually model this reward variable in a meaningful way, because if you have no concept of reward, like if you have just win and lose for an agent, we might not be able to actually provide a meaningful explanation, at least based using rewards. But you can still have a causal chain that leads to are the other variables, but maybe not an reward. So yeah, it might not be meaningful to have explanations not based on rewards, I would say.
Yeah, thank you for the answer. That was interesting. Also, just to add on to it, and also I think it illustrates to the point of the emergent behaviors which come into the picture when you're training for a sparser reward, and relating those emerging behaviors to the explanation seems like an interesting direction. At least what I got from your answer.
Yeah.
Super. I'll give the word to Glenda again.
Yeah, I have another question. It's in a more methodological direction. I'm wondering, you mentioned that you also evaluated this framework with human participants. Mm-hmm. And I'm a little bit curious, how did you measure whether, like which tools, exact methods did you use to check if people find this explanation good?
Mm-hmm. Right, so that's a really good question. So there's this really good paper from a DARPA XAI program that talks, that gives a guideline of how to evaluate explainable systems. So we use the question, so to evaluate, let me go to the, so mainly these metrics are all from that paper. So if you, here you can see is Robert Hoffman, Mueller. It's called Metrics for Explainable AI. So these are the metrics that was described in this paper. This is a very similar paper. So task prediction is a really key kind of quantitative method we can use. So basically we are trying to, the basic concept is we want to give explanations of the agent's behavior and then educate the participant or make the participant understand the agent's behavior, and then question the participant by showing a new behavior of the agent, and to see, okay, can the participant now predict what the agent would do next, right? So if the human has a good model of the agent in their head based on the explanations that were provided, they should be able to sort of predict the agent's behavior. So for example, if the agent is very aggressive and playing very aggressively, and the explanations are like reflecting that, and if you give a similar scenario, and you should be able to predict what the agent would do next, right? So yeah, this is a quantitative measure, and there's this explanation quality. This is from an explanation survey. So you give a survey for like a scale survey to the participant. So there are measures like completeness, sufficient detail, satisfying, understanding. These are all metrics that were described in this paper. And also trust is also another survey from that paper.
Yeah, that's really nice. And I was really wondering about the understanding. Yeah, I'm trying myself in my research to figure out how do you measure if people understand something. And I would just intuitively think that you need maybe some follow-up questions or a bit more mixed method approach than just surveys.
Yeah. So these two were surveys. These are like just a score of how well they would do, right? So we would show 8 new scenarios and let the user or participant predict what the agent's actions would be, and then if they got right, they would score 1 point, like that. So this is a scale of like, I think 2 points, and then this is a scale of 0 to 16. Yeah, so that's a quantitative kind of measurement. So that's really checks the understanding of the participants, kind of query the participant's mental model of the agent.
Okay. Are there any other questions? Okay, I will make you a very small, like, I just want a clarification because you mentioned that your system is model agnostic. So in the sense that after there is some learning, you have this structural causal model that is a kind of super layer. So I was wondering if there is like if we can interpret this as sort of what happened when you have LIME or SHAP or those kind of systems. Mm-hmm. So can we consider this method something like that at the end of the learning, reason upon the learning and give us an explanation based on the causal model that you are giving at the end?
Yeah, they're pretty similar. I would say that that's the exact kind of thing that is happening. So LIME is also a surrogate model, right? So you still have the underlying model, and you use like a linear model to explain that underlying model, right? So this is the same thing. We are using a causal model to explain the underlying reinforcement learning agents, because explaining a kind of a deep reinforcement learning agent is using their own model is very hard and not very interpretable. So this is a interpretable model that is more basic, but also useful for explanations.
So it's really something you do at the end on top. So I think like this relates also with the question of Akpin about the sports reward. I mean, the problem does not succeed so much if you do the interpretation at the end. I think.
Yeah. So this. You can train. So for example, you can train an agent and get the training logs and the state traces and like train this model. And this model is like you can use two models when you make the decisions of the agent. You can use the actual model, and when you explain, you can use this model.
Okay, so thank you, everyone. I will take, if there is no more questions, I will take these last 5 minutes to introduce the next speaker. So if I can share my screen.
Sorry, yeah, let's stop sharing.
Okay. I'll share again my screen. So the next session, we will host Joara Nazir from Computer-Human Interaction in Learning and Instruction Laboratory from EPFL in Lausanne, Switzerland. And she will talk about what if social robots looks for productive engagement. So she will talk about engagement and how to automatically assess engagement in learning applications. So thank you, everyone. I'll stop again sharing.
And I want to thank the organizers as well, and for inviting me to the talk.
It was great, and thanks, because for you it's really a hard time.
Oh, that's fine. I can sleep. It's tomorrow's Saturday anyway.
Okay. Yeah. So thank you, everyone. And for any other question, please don't be shy, and you can add them on our Slack. I'll share again our Slack link and close the session.
Thank you, everyone.